compound, what does it mean to compound, be compounded or compound something, or what's the word in general mean?
It's like adding something to something else.
Yeah. So a compound event is a combination of two or more events. Okay. Right? And it uses the word and or the word or. Because there's two types of events. You've got your or events, and then you have your and events, okay? And just like when we were talking in the set theory, our or events uses the U symbol, and our and events uses the upside down U symbol. Okay, so still going to mean kind of the same thing. All right. Okay, there are two kind of events for each of those that you have to kind of classify. You have mutually exclusive. Okay, and what that means is that the events with no common outcome. Okay, so a good example for that would be if I wanted to find the probability that you were a freshman or a sophomore. You can't be both. You're one or the other. Okay, so an example is being a freshman or a sophomore. Okay, and to find it, you would say, okay, I want the probability of a freshman or a sophomore. And so I find the probability of being a freshman, and I find the probability of being a sophomore, and it's basically an addition rule. Good so far? Does that make sense? Okay. If they are overlapping, okay, that is an event that has a common outcome. Okay, so let's say you're being a boy or playing baseball. Okay? Because Nick is both. All right? So to find that, and the common is to use A and B as like examples. And I'm going to do that because otherwise I'd have two B's and that would be confusing. I'm going to find the probability of being a boy. And I'm going to add that to the probability of playing baseball. But I just counted Nick twice, right? Because he was in the one group and then he was in the other group. So he's in there twice, so I need to take out those that are in there twice. So I take one of them out. So if you think about our Venn diagram, when we were doing the probability, here I'd have 1/8 plus 3/8, and then I would take out the 3/8 because they're in both. They're already got counted. Okay, does that make sense? All right, those are your ors, and you basically add. If you have and, then, or in intersections, then you multiply, okay? And we have two different kind. We have independent events. What do you think the independent events are? They don't, yeah, they're events that do not affect each other. Okay, so, let's say I want the probability of flipping a coin and rolling a die. If I flip that coin first, it is going to have no effect on rolling a die because it's two completely separate things, right? So I don't have to worry about either one of those. And so the probability of flipping my coin and rolling the die, I multiply. I find the probability of each of them, and then I multiply. Okay? Good so far? All right, last one. Let's do purple. Okay, if it's dependent, what do you think that means? They do affect each other. Yeah, it's events that do affect each other. Okay, so let's say I have a deck of cards and I want the probability of drawing two cards. My first probability, let's say I want to find the probability of drawing an ace. Okay, there's 4 aces and there's 52 cards. But let's say I draw the card out and I don't replace it. That affects the probability the second time because now I only have 51 cards. All right, so that's what's called without replacement. Okay, and it's the same thing for my rules. I'm going to find the probability of the first one, and I'm going to multiply it by the probability of the second one given A. So I figure out what I'm doing to the second one based on what's going on. Did I put the card back in? Did I not put the card back in? Peyton, which one? Probability of B given A. Good so far? So when you're trying to figure out your probability, the main thing is that you need to just say, okay, what kind of event is going on? And then you can just figure out your rule. All right? Ready? Let's do some. Got all sorts of examples. I know. It just thrills you to no end. Okay. First off, I randomly choose a card from a standard deck of 52 playing cards. Find the probability you choose a queen or an ace. All right. What's the key word? Or. That's my key word. It's one or the other. So, then I look at, is it mutually exclusive or do they overlap? Does it matter? Am I going to pick a queen and an ace at the same time? No. It's one or the other. They're completely dependent. Okay? So that means I just need to find. So it's the probability of a queen or an ace. So the probability of the queen plus the probability of the ace. Good? All right, so the probability of the queen is 1 out of 52. Agreed? The probability of the ace is 1 out of 52. Agreed? Oh, thank you, both of you. Hands up at the same time. That was awesome. How many queens are there?
4.
There's 4. And there's 4 aces. Perfect. So that means I have 50 seconds. So that means I have a 15.38% chance of drawing a queen or an ace. Good so far? Yes? Yep. All right, next one. Probability. I choose a king or a club. There's my or again. So that means I'm using the addition rule. Okay. Now, is it going to be overlapping or are they exclusive? It doesn't matter. What do you think? You think it's exclusive?
No, it's okay.
Why do you think it's overlapping? Because you can have a king of clubs. So that means that I'm going to find the probability of A, the probability of B, and then I'm going to subtract out my duplicates. Right? So probability of A, for my kings, is 450 seconds. How many clubs do I have? 13. And how many king of clubs do I have? 1. So I take that one out. So that means my probability is going to be 4, since these are all the same. So 4 and 13, 17. Minus 1 gives me 16 50 seconds, which is 30.8%. Good? All right. Choose a card with an even number or a heart. Okay. Or, so I know I'm doing addition. Are they exclusive or do they overlap? It overlaps because I can have an even heart. So how many even cards are there? That's the hard part, right? Okay, so I got My sample space would be 2, 4, 6, 8, and 10. And I have 4 suits, so 4 times 5 is going to give me 20. Would you agree with that? Ace is not, number 1 is not a number, but if we count it as a number, it would be a 1. Okay, how many hearts do I have? And how many even hearts do I have? Well, 1, 2, 3, 4, 5. Are we good with that? And so when I subtract and add, I'm left with 28 50-seconds. I'm sorry.
I'm going to sleep.
No, you're not going to sleep. Here, have some sugar to wake you up. All right. Find the probability you choose a heart or a spade. Or, so I know I'm adding. Are there going to be any duplicates? No. So I just need to add the two together. So I have 13 hearts. I have 13 spades. And so I get 26 50-seconds, which is 50%. Are we good? Yeah? All right. A coin is tossed and a 6-sided die is rolled. What's the probability that the coin shows heads and the die shows a 5? Are they independent or dependent? They're independent. It does, one is not going to affect the other. Okay, and so if it's independent, the rule was just to multiply. And so if a coin is tossed, I can either get heads or tails. Would you agree with that?
Yeah.
And the die shows a 5, so I only have one choice of 5. How many sides does a die have,
6.
typically? Yeah. So that gives me a probability of 1/12, which is 8.3%.
Where do you get 12?
Because 2 times 6. When I'm multiplying fractions, I just go straight across. Good? Thank you for asking. All right, what's the probability a coin shows tails and, so that means I'm multiplying, the die shows an odd number? Independent or dependent? Independent, so just multiply across. Coin shows tails, so that's 1/2. How many odd numbers do I have on that die? So I would end up with 3/12. Which is my 25%. Perfect. Good? Okay, so I have an aquarium. We have 6 goldfish and 4 female, or 6 male, 4 female. I randomly choose one from the tank without replacement. What does that mean? It means I don't put it back in and he died.
Oh, that means that it like messes it up. You did it probably with the
Okay. Then I select another one. What's the probability both fish are male? So I need to look at the first one. I have, how many total fish do I have? 10, the 6 and 4. And what's the probability that the first one's male?
1/10.
I have 6, right?
Can you do those six balls
Because that's what it says. Okay, and I'm going to multiply. Now, the second time around, how many fish do I now have in the tank? 9. How many male do I have now? 5, because we're going off the fact that we're saying we pulled a male out the first time. And so that gives me 30 over 90, which is 33.3%. Okay, so let's think about what we have. We know if they're independent. If they're independent, that means that they don't affect each other, right? It's just when you multiply the two together, it's going to be the same, right? So to see if they're independent, multiply, follow your rule, to see if you get the same thing. So I know that the probability of A is 0.5. I know my probability of B is 0.7. And that gives me 0.35. Okay, you with me on that? Since 0.35 is what's given, then yes, they're independent. So on the next one, if I say, okay, well, 0.3 times 0.2, what does that give me? 0.6. Is 0.6 the same as 0.5?
No.
No, so no, they're not independent. Good? All right, let's do a table. All right, my totals are 40, 40, and 80. I have 48 with a job and 32 no job. All right, find the probability of J and T. So this means it's an and. That means I have to multiply. And J is job and T is 12th grade. So do I have, are they independent or dependent? They're dependent because I could have both, but honestly, I already have both of these combined here, right? There's my 30. How many total students do I have? 80. When you have charts, they've already done the math for you. You can just pull the numbers off your chart. All right, so that gives me a 37.5%. Okay, N is no job, T is 12th grade, but this time it's an or, right? So that means, do they overlap? Yeah, I have some that overlap this time. So the ones with no job is 32. I have 40 total seniors, and I have 10 that overlap. Oops, I guess it helped if I showed you the whole page, right? Does that make sense to you? So that gives me 58 out of 80, which is 72.5%. Does that make sense? 32. Oh. And no job. Oh, because I just didn't add, right? I picked up the number from the wrong one. So that'd be 62, right? 72 minus 10, 62, yeah. So that's going to change my percentage. Thanks, good catch. Picked up the wrong one. All right. Probability of no job and junior. So no job total is my 32. I have 40 11th graders, and I have 22 so that gives me a total of 50 divided by 80. Yeah. No, because these are all of them in the sample. So you have to take all of them in the sample, but that's why I'm subtracting out those that are duplicated. Okay? You replaced it yesterday.
Okay.
Good?
You wanted Del War?